Hi everyone, welcome to MathWorld. This video is to discuss Cambridge International AS and A-Level Mathematics Paper 5, which is the Probability and Statistics 1 for May-June 2022, and the code is 9709/51. Okay, so let's move on to number 1. So for question 1A, find the number of different arrangements of the 8 letters in the word deceived, in which all 3 E's are together and the 2 D's are together. Okay, so first of all, for the word of deceived, right, so we have 8 letters in total, and there are 2 D's. Then we have 3 E's. After that, 1 C, 1 I, 1 V. Okay, so 1 C, 1 I, 1 V. Okay, so now to get 3 E's together, that means now I will get 3 E's in a group and then 2 D's in another group. But then it doesn't mention that it must start with 3 E's, alright? So it means that basically we treat these two groups, or we treat the 3 E's as one group. So this is 1, here is 1, another 3 different letters, CIV. So I will treat this as 5 different letters. Therefore, the number of arrangement is very simple. So number of arrangements is just 5 factorial, which is 120, because there's no difference among the 3 E's and the 2 D's. Okay, so done for 1A. Now B, find the number of different arrangements of the 8 letters in the word deceived, in which the 3 E's are not all together. Okay, so when the 3 E's are not all together means that you have to use 3 E's, or I would say and 3 E's are not all together. It is the same as number of arrangements without restriction minus the number of arrangements when the 3 E's are together. Okay, so when the 3 E's are together means that now 3 E's treated as one group. Then you have another 5 letters, 1, 2, 3, 4, 5. But out of the 5, you will have 2 D's. Alright, so now from these 5 letters together with the 3 E's will be 6 letters. Alright, so now when we come back to the without restriction, means that is the solution from previous part. It's different. Okay, now 3 E's are not together means that now we have 8. Alright, so 8 factorials. Out of 8, we have 3 E's, 2 D's. So 3 E's, 2 D's, because they are repeating. Minus, when 3 E's are together, so since I have explained just now, treat these 3 E's as 1. And then you have 5 more here. Alright, so the 5 plus this 1 becomes 6. Therefore, there will be 6 factorial. But out of this 5, we have 2 D's. So you must divide by 2 factorial. Okay, so the first calculation is 3360 and the second calculation is 360. So at last you will get 3000. This will be the number of arrangements that satisfy this condition. The 3 E's are not all together. Okay, so done for the question 1B. Now question 2. There are 6 men and 8 women in a book club. The committee of the club consists of 5 of its members. Mr. Lan and Mrs. Lan are members of the club. Alright, basically there are 6 men, 8 women. And from here you need to choose 5, because 5 will be the members. Mr. Lan and Mrs. Lan are members. Alright. So now from this 5, it includes Mrs. Lan and also Mr. Lan. Right. Now A, in how many different ways can a committee be selected? So the arrangement is not important. If exactly one of Mr. Lan and Mrs. Lan must be on the committee. So it's mentioned exactly one, cannot be both. So now we have to choose. So now when Mr. Lan is in the committee, Mrs. Lan is not. Okay. And when this is all. Second option is Mr. Lan is not in the committee, and then Mrs. Lan is in the committee. Okay, so remember, here total 5 and 6 will be 14. Okay, at first total 14, but this 14 including Mrs. and Mr. Lan. Alright, so when you consider the first condition, Mr. Lan is included. So 1C1. This is for Mr. Lan. And we need to get 5, right? So means Mr. Lan is selected. We need 4 more. Okay, so this 4 more means that Mr. Lan is selected. So from here, right, you cannot say 14 minus 1 because when you have selected Mr. Lan, make sure you don't select Mrs. Lan because it's mentioned exactly 1. So it means that now instead of 14, right, so 14 you have to minus 2, becomes remaining 12. So now Mrs. Lan is not selected. Alright, it means that now in order to get 5 members, I need to choose another 4 from the 12. Okay, so therefore 12 choose 4. All is plus. Plus. Now another option is Mr. Lan is not selected. Okay, Mrs. Lan is selected. So now again, when Mrs. Lan is selected, means 1C1. You can just ignore the 1C1 if you want. Okay, if not, you can just write 1C1 to represent Mrs. Lan is selected. And at the same time, make sure you don't choose a Mr. Lan. Alright, that means we still need to minus 2. So we have to minus both. Alright, means that now we need to choose another 4 from the remaining 12 to make it to 5 person in the club. So I times by 12C4. Okay, so that is the number of ways. Right? So when you count this value, it will be 495 plus 495. So I will get 990. So we have 990 ways to choose the members. Okay? Now B. In how many different ways can the committee be selected if Mrs. Lan must be on the committee? And there must be more women than men. Okay, so I will rewrite. We have 6 men, 8 women. Alright, so now Mrs. Lan must be selected. So Mrs. Lan selected. And then we have to make sure more women than men. So now Mrs. Lan is selected. So this including Mrs. Lan. Alright, so I could say that we choose all the women. Alright, so from here we need to choose 5. So I need to choose another 4 women. Okay, or I have Mrs. Lan, and then I consider 3 women and 1 man. Then it could be Mrs. Lan is selected, 2 women and 2 men. So in these 3 cases, we will make sure that Mrs. Lan will be committee, and there will be more women than the men because maximum men here is only 2. Then we'll have maximum of 3 women. Okay, so from here I will say that number of ways equals to, okay, Mrs. Lan is selected, so 1C1. And I need 4 women. So at first we have 8 women. This 8 women inclusive Mrs. Lan. So if you exclude Mrs. Lan, means that basically it consists of Mrs. Lan and another 7 women. Okay, so it means Mrs. Lan is selected. Then I have to choose the remaining from the 7 women. So it will be 7, choose 4 for the first condition. Okay, or Mrs. Lan is selected, so all is plus. So when Mrs. Lan is selected, 1C1, and I need to choose 3 women from this 7. So it will be 7C3, followed by 1 man from 8. So 8C1. Okay, not 8. The man is 6. Sorry, man is 6. I overlook it. So it will be 6. Alright? Or, okay, the third case. So when the third case, Mrs. Lan is selected. So 1C1. And we need 2 women. So 7, choose 2. And we need 2 men. So 2 men means that 6, choose 2. Okay, so 6, choose 2. Right? So the first value is going to be 315. Then the second bracket is 210. And then the last bracket is 315. So the total is 560. So these are the ways to choose a committee. With the condition, Mrs. Lan must be in the committee and there will be more women than men. Right? Okay, so let's move on to question 3. The times taken to travel to college by 2,500 students are summarized in the table. So time taken in T minutes, the T from 0 to 20 as the first group, 20 to 30 until 90. Frequency will be 440 to 720 until 120. So that the total is 2,500. Now draw a histogram to represent the information. Okay, so now from here, let's look at the time taken interval. So the first interval, the width is 20 because 20, the average, right? The average of these two values is 20. So 20 minus 0, the width is 20. But then for the next one, the width is only 10. So because of different intervals, that means you have to calculate the frequency densities. Alright, so I better rewrite this table because we need to do the calculation. So here I will write T for time. Then this is frequency for F. So now I will write class width. Let it be C. Okay, then I need frequency density, which is frequency over class width. Okay, so for the first class, 0 to 20, the frequency 440. Now the class width, just now I have mentioned, the average of these two values, which is 20, minus average of the previous value, it should be 0. So 20 minus 0 is just 20. Alright, so now for the next class, which defines from 20 to 30, then 720 here. The average of these two values, the boundaries, will be 30. Then here is 20, so 30 minus 20, width is 10. Then the next is 30 to 40. So 30 to 40, the width is 10. Then 40 to 60, again here is 60, average. Here average is 40. So 60 minus 40, it will be 20 here. And then from 60 to 90, it will be 30. Alright, so now I will rewrite the rest of the frequencies. So now the frequency density is frequency over class width. So 440 over 20, you will get 22. Then 720 over 10, it will be 72. 920 over 10 is 92. 300 over 20 is 15. 120 over 30, it will be 4. Okay, so now we need to draw histogram. So histogram, we need the frequency densities in the vertical axis and the class boundaries, which means here this will be the class boundaries on the horizontal axis. So it means that my horizontal axis will be from 0 to 90. My vertical axis will be up to 92, means maybe up to 100. Okay, so now by looking at this graph, okay, I will start with here. This is a time taken, t minutes. Here will be 0. Let me check the interval first, because we need to include 0 and 90, up to 90 for the t. So I will let it be 20 each. Right? And then for the frequency densities, we need to include up to 92, from 4 to 92. So I will let it be 20 each as well. Right, so here is going to be frequency densities. Okay, so now from here, just mark accordingly. So when 0 to 20, first class, it is 22, the height. So 0 to 20, 22. That means here is 30. So each square is representing 2 units. So I will get this height. Okay, there's the first bar for my histogram. Hang on, please. Right, now my second bar is going to be 20 to 30. The height is 72. So 72. So here is 70, 72. 20 to 40. Sorry, 20 to 30. So means it is half. So please draw using ruler. Right. Then the next bar is 30 to 40. The height is 92. So 92, here is 90, 92. Alright, so please draw using ruler. Okay, this is the height. Okay, there's the third class. The class 40 to 60, the height is 15. So 40 to 60, the height is 15. Here is 10. So 12, 14, 15. Alright. So it's in the middle. Okay. Then lastly, 60 to 90, it is just 4. So 60 to 90, 90 is over here. 4 means 2 squares. Alright, so this is a histogram. So here you can just write histogram. Alright, so done for this part. Now, from the data, estimate the estimate of the mean value of t is 31.44. So this is a mean value, means that this is a t bar, 31.44. Now calculate an estimate of the standard deviation for the times taken to travel to college. So now standard deviation, we need to count all the frequencies, right? So from here, standard deviation, I will write standard deviation equals to square root of summation fm square over summation f minus mean square. Okay, because you are given the mean already. So now what we need to do now here is we need to get the m. So I can refer back to my previous table and add on the m. M is representing the midpoints. So I will add on the m over here. This is for next calculation. So now my m will be average of these two limits. Okay, so 0 plus 20, it will be 20 divided by 2, I will get 10. So then the next one is 20 plus 30 divided by 2 will be 50 divided by 2, then you'll get 25. Then after that, the next class, 30 plus 40 is 70, 70 divided by 2 is 35. Then 40 plus 60 is 100, divided by 2 is 50. Lastly, 60 plus 90 is 150. 150 divided by 2 is 75. Okay, all these are my m. So now, my calculation is summation fm squared. Means that all my f here, okay, multiply by its m. Then you square the m. Alright, so first value will be 440 times 10 squared. Then followed by 720 times 25 squared, and so on. Okay, so I will just write here. So it will be square root of 440 times 10 squared plus, next is 720 times 25 squared. Then plus 920 times 35 squared. Then plus 300 times 50 squared. Then 120 times 75 squared. Over total f. Okay, summation f is a total f. So the total f here is 2500. This is a total f. Okay, minus mean squared. The mean is given 31.44. So I have to minus 31.44 squared. Alright, so it's not very clear. Alright, so this is the calculation. Alright, then here you will get 15.2. Okay, then the B. Now C, in which class interval does the upper quartile lie? So upper quartile means that it is upper quartile. There's a data with 75%. That means it's going to be 75 over 100 times 2500. So you will get, this is data number 1875. Okay, after you arrange it, this is a position. So now from here, we need to get the capital F, the cumulative frequency. So now the cumulative frequency is counted using the frequency here. You just keep adding. Alright, so my first class 0 to 20. So here 0 to 20. Then 20 to 30. After that 30 to 40. 40 to 60. 60 to 90. Okay, so here is the T. This is my F. So I will just rewrite. My F is 440, 720, and so on. So I will just copy back all the values. So 440, 220. After that, 720, 920. So here is 720, 920. Then 300, 120. Okay, now my capital F, which is the cumulative frequency. Right. So now the first one is 440. So when you add up both of them, 440 and 720, you will get 1160. And then 1160 plus 920, it will be 2080. Then you plus 300, then you get 2380. And then you plus 120, it will be 2500. So now our upper quarter is the data number 1875. So obviously 1875 is in the third quarter, I mean the third group. Okay, because the previous group is up to data number 1160. So upper quarter class or interval. Okay, class or interval. So it will be 30 to 40. Right? Okay, now, it was later discovered that the times taken to travel to college by two students were incorrectly recorded. One student's time was recorded as 15 instead of 5. That means the actual is 5. Okay? And the other time was recorded as 65 instead of 75. Alright, so there are two mistakes here. D. Without doing any further calculations, state with a reason whether the estimate of standard deviation in parts B would be increased, decreased, or stay the same. Okay, so now let's look at the interval. So when it is 15, right, the recorded data is 15, so it means that it is in first quadrant. I mean, not first quadrant, it is in first interval, 15. Okay, the second one, the wrongly recorded was 65, so it is in last interval. But then we know that the actual is 5 instead of 15. So 5 is still in the first interval. Okay, the second one supposed to be 75. So 75 is still in the last interval. So from here, when you look at the calculation of standard deviation, okay, let's go back to the parts B. So for calculation of standard deviation, we need the F and the M. Alright, now F and the M and also the mean. So basically the mean is also referring to summation Fm over summation F. This is the formula for mean. Okay, so basically for the calculation of standard deviation, we need to refer to the F and also the M. Now let's look at the data now. Okay, so the actual data 5 is in the same group as the wrongly recorded data 15. Right, which means there's no effect on the F and also the M, because the M is counted using the boundaries. Okay, the limits, lower and upper limits. Same for the 65 and 75. Supposedly 75, but it is wrongly recorded as 65. So, but anyway, they are still in the same group. Okay, which means in terms of the calculation of standard deviation, it will not have any effect because we don't use the actual value to count. We are using the F and M. Okay, the M is counted using the upper and lower limits, right? So therefore, the answer for the part D is standard deviation stays the same. Stays the same. Okay, we need to give reason. Right? Why? Because the theta will be in the same interval, right? As theta still in the same interval. Okay? Still in the same intervals. So it will not affect the calculations it will not affect the, I would say, the frequencies and midpoints. Alright, so it will not affect the frequencies and midpoints. In the calculation of standard deviation. Okay, because they are in the same group and we do not use the actual value to count. We just refer to the frequencies and midpoints. Alright, so that's the solution for part D. Okay, now let's move on to question 4. Jacob has 4 coins. One of the coins is biased, such that when it is thrown, the probability of obtaining a head is 7/10. So PH, let's say this is for the bias coin, this is 7/10. That means PT1 is going to be 3/10. But the rest of them, it will be half. So Jacob throws all 4 coins once. The number of heads that he obtains is denoted by X. Then this is the probability distribution table. Now you are given the A, B, C here. Now show that A equals 1/5 and find the values of B and C. Okay, so now your A is the probability when the X equals to 1, means that you get 1 H. Okay, so now A equals to P 1H, Px equals to 1. Px equals to 1 means that it could be the bias coin shows 1, and then bias coin shows head, and the rest of the fair coin shows tails. So I will write PH means fair coin. Okay, PT means a tail for fair coin as well. Right. Or it could be the bias coin shows tail, and then 1H, 2T for the other 3 fair coins. Okay, plus PT1, then TH, T, as long as just 1H from the other 3 fair coins. So T1, T, TH. Right, so when H1 means that 7/10, then 3T means half to the power of 3, because each coin has the same probability, so you multiply by 3 times. Or T1 is 3/10, then HTT is basically half, right? Because here half, here half, here half. So half power 3. And the next one is also the same. So you can plus 3 times, or you just direct plus times 3. It's up to you. So I will just direct times 3, because these 3 probabilities are the same. Right? So when you calculate, it will be 7/80 plus 7/80. That means you are getting 14/80. Then it will be 1/5. Oh, sorry, the next one is 9, not 7. Here is 9. So 9 plus 7, it will be 16. Therefore, you are getting 1 over 5. Alright, so now, to get the C, or I will count the C first instead of B, because it will be easier to count. So when Px equals to 3, so 3 heads. So now, the C is Px equals to 3. So when 3H means that you might get the bias coin show H, then another 2H and 1T. Okay, and the bias coin show H, then you get HTH. Or the bias coin show H, then you get THH. These are the 3 heads. Or, okay, the bias coin shows tail, and then the other 3 fair coins show head. So now, H1, PH1. H1 is 7 over 10. Then PH is same as a PT for the fair coin. Therefore, it's half to the power 3. Okay? And again here, you get 1 H1, you see? H1, H1. And then followed by 2H, 1T. Here also 2H, 1T. Here also 2H, 1T. Therefore, I can just times 3. Because they will be the same for the first 3 probabilities. Now, plus, the next one is PT1. The T1 is 3 over 10. So here it's going to be 3 over 10. Then H is half, and there are 3 times, so power 3. Then I will get 21 over 80 plus 3 over 80. Then your C is going to be 24 over 80, which is same as 3 over 10. Okay, that's my C. Now to get my B, very simple. Just 1 minus the rest. Alright, so I will continue my B over here. 1 minus the rest. So 3 over 80 plus 1 over 5 plus 3 over 10 plus 7 over 80. So you use 1 minus all this. Right, 1 minus all this. Then you will get 3 over 8. So this is how we solve this question. Right, so now B, find EX. So EX is summation X PX. So when summation X PX, look at here, the first X is 0, so no need to count because X times, 0 times 3 over 80 is still 0. So I will count 1, 2, 3, 4 for the X values. So 1 times A, alright, so 1 times 1 over 5. Then the B value is, the B is the probability when X equals to 2. So it means 2 times 3 over 8 plus 3 times C, okay, because the C is when X equals to 3. So it is 3 over 10. Plus 4 times the probability. So 7 over 80. So we count all this, it will be 11 over 5. Or you may just write 2.2. So that's the expected value. Okay, now, Jacob throws all 4 coins together 10 times. Alright, find the probability that he obtains exactly 1 head on fewer than 3 occasions. So when he repeats this experiment for 10 times, this becomes the binomial experiment. Therefore, now my X is binomial, the N is 10, and now you need to get exactly 1 head. So when exactly 1 head, the probability of getting that is A, alright, which is 1 over 5. This is our probability. So 1 over 5. And now you will get exactly 1 hit on less than 3 occasions, means that less than 3 throws. So px less than 3. So when px less than 3 means the x from 0 until 2. So px equals to 0 plus px equals to 1 plus px equals to 2. Right. So now for binomial formula, right, binomial distribution, x is b and p. The probability of x equals to small x is going to be ncx px qn minus x. Alright. So now by using this formula, the first one is going to be, okay, because x equals to 0, so any value c0, it will be 1. Then p power 0 is also 1. Alright, so we just need to count the q. So now your p is 1 over 5, that means your q is 4 over 5. So now I will write 4 over 5 to the power of 10, because no success means that all 10 are failures, plus 10c1, only one success. So 1 over 5 degree 1 times 4 over 5 degree 9, plus 10c2, 1 over 5 degree 2 times 4 over 5 degree 8. Okay, so when you count the total of these probabilities, it will be 0.678, correct to 3 significant figures. Okay, so that's all for the solution of this question C. Now D, find the probability that Jacob contains exactly one head for the first time on the 7th or 8th time he throws the 4 coins. Okay, this means he has thrown 7 times. So 1, 2, 3, 4, 5, 6, 7. This is the 7th throw. And this is the first time he get 1 H. Right? Or I will say that all this is H. This is the first H. All the previous 6 times will be tails. Or he has thrown 8 times. So 1, 2, 3, 4, 5, 6, 7, 8. This is the 8th throw. And this is the first H because it's mentioned first H. Right? So it means that here you are getting 7 tails. All previous throws are showing tails. So these are the properties that you need to find. So basically this is geometric distribution. Okay, so now you can just write probability equals to, okay, so from here to get a H, 4 coins, okay, you see, look at here. If he gets exactly 1 H, the probability is 1 over 5. Alright, so now basically here you can write PH is 1 over 5, which means PT is going to be 4 over 5. Alright, so now from the first case, you get the first H on the 7th row. That means the first 6 will be 4 over 5 probabilities. And each row is independent. Therefore, you multiply for 6 times. I will just say that it is power 6 of 4 over 5. Then multiply by 1 over 5. That is to get the H. All is plus. Now, 70. Alright, that means it's 4 over 6 to the power 7. Multiply by 1, oh sorry, not 7 over 6, it's 7 over 5. 7 over 5 to the power 7, sorry, 4 over 5 to the power 7 times 1 over 5 to the power 1 to get the last H. Okay, then from here when you add up both values, it will be 0.0944. 3 significant figures. Okay, so this is how we solve the D. This is basically geometric distribution. Now number 5. The lengths in centimeter of the leaves of a particular type are modeled by distribution and 5.2 and 1.5 squared means that this is normally distributed. Find the probability that a randomly chosen leaf of this type has length less than 6 centimeter. So here x is normally distributed 5.2 and variance 1.5 squared. Now you need to count px less than 6. So standardize it. So when you standardize, you use 6 minus 5.2 over standard deviation. So standard deviation is basically 1.5. Ignore the square. So then you will get p z less than 0.533. So when less than 0.533, basically when you refer to the normal graph, okay, the normal table, middle is 0. The 0.533 is on the right hand side. Because of less than, the region is towards the left hand side. This region is exactly same as the one in the table. Therefore, you can just read the probability from the table and it gives you 0.7029. So at last, it will be 0.703. Alright, so that's the A. Now the lengths of leaves of another type are also modeled by a normal distribution. A scientist measures the length of a random sample of 500 leaves of this type and finds that 46 are less than 3 centimeters and 95 are more than 8 centimeters long. Find estimates for the mean and standard deviation for the length of leaves of this type. Okay, so now we need to find mean and standard deviation because it's mentioned they are normally distributed. Unfortunately, the mean and variance are not given. Okay, so now here I will write y is normally distributed, mean mu, variance sigma squared. And then now the n is 500. So the probability of y less than 3, okay, less than 3 centimeters. Now you are given 46 is a number of leaves. So now to make it to probabilities, it will be 46 over 500. So now I will standardize it. So 46 over 500 is basically 0.092. Okay. Then the next is I can just draw the graph first if you want. So from here, right, now we are not sure where is this line, 3 minus mu over sigma. It can be on the left hand side or on the right hand side. So but then it is less than. And for your information, if it is pz less than 0 or pz less than 0, the probability here is 0.5. But then since this probability 0.092 is less than 0.5, that means the region is on the, the line is on the left hand side. Okay, therefore this is 3 minus mu over sigma. And this probability is 0.092. Okay, this is how we decide where is the line. It's on the left or on the right. Now, the next value, the next probability is more than 8. So py more than 8. And there will be 95 out of 500. So 95 over 500 for your probability. So now I standardize it. Again, 95 over 500, you will get okay, let me count what is the value first. It will be 0.19. Okay, so now here I will get this value. Okay, then this is going to be another graph. Okay, I supposed to solve this first. Alright, so let me erase this part. Let me complete that first. I need to get one equation in terms of mu and sigma before I consider the next probability. So since it is less than, it is on the left hand side, what I need to do is I need to reflect or flip it to the right side. Then here is going to be 0.092 and this is negative 3 minus mu over sigma. Okay, and since this is normally distributed, then I know that the total probabilities to the left hand side will be 1 minus 0.092. So I will just write p z less than or z less than negative 3 minus mu over sigma is 0.908. How to get this? It's 1 minus this value. Okay, here is basically 1 minus 0.092. Now from the table, since it is 0.908, then you can read from normal table. So from table, B, Z or Z less than 1.329 equals to 0.908. That means now I compare. Negative of the bracket equals to 1.329. Okay, then I will get negative 3 plus mu. I times in the minus, and then the sigma move to the other side equals to 1.329 sigma. This is my first equation. So after you have done up to here, then only you consider the next probability. So the next probability is more than 8, and it is 95 over 500. So now here, By more than 8, it is 95 over 500. Again, we standardize it. Okay, so 95 over 500 is 0.919. So now draw the graph. The line is on the right hand side because it is small, and if it is on the left hand side, it must be more than 0.5 because when more than 0 is already 0.5. Right, now you are getting less than 0.5. The probability is only 0.19. That means here is 0.19. So when the shaded region is 0.19 means that the previous region here is going to be 1 minus 0.19. Then you will get 0.81. So I will write B, Z or Z less than 8 minus mu over sigma is going to be 0.81. Alright, then from here, I will write from table. B, Z or Z less than 0.878 is going to be 0.81. Okay, so now compare both of them. So I will get another equation. 8 minus mu over sigma is going to be 0.878. Then my 8 minus mu is going to be 0.878 sigma. This is my second equation. Okay, just now we have found the first equation here. Minus 3 plus mu equals to 1.329 sigma. So now to eliminate the mu, I will just plus both. Let me check. I will just plus both equations because the first one is plus mu and the second is minus mu. So now first equation plus second equation, and then you will get 5 equals to 2.207 sigma. Then from here your sigma is 2.2655, which is 2.27. Okay, so for final answer, we round up to 3 significant figures, but later on we need the sigma value for the mu calculation. Therefore, I will use 2.2655 in the calculation. So from first, okay, I will use back the first. So to get a mu, just move the minus 3 to the other side. So it will be 1.329 times sigma. So now my sigma is 2.2655 plus 3. So then here, final answer, you round up to 3 significant figures. So this is how we count the mu and sigma when you are given 2 probabilities. Okay, now see. In a random sample of 2,000 leaves of this second type, how many would the scientists expect to find the lengths more than 1 standard deviation from the mean? Okay, now let's say for example, this is the diagram. Here is the mean. This is 1 standard deviation. Here is 1 standard deviation. Okay, it's mentioned more than 1 standard deviation from the mean. That means you are counting more than this value. So this is going to be mu. Let's say the mean is mu. Okay, because this is a second type. So it means that this is going to be mu plus 1 sigma, and this bracket is going to be mu minus 1 sigma. So now you need to count the probability of outside. Right? Now I will say it is P y more than mu plus sigma, or P y less than mu minus sigma. Then now again we standardize. I will not replace the mu and sigma first, because later we can cancel off the terms. So when you standardize, you always minus mean over standard deviation, plus the next value is going to be mu minus sigma, then you minus mean over standard deviation. So from here you will find that mu minus mu is 0, sigma over sigma is 1. Okay, then here mu minus mu is 0, minus sigma over sigma is minus 1. So basically you are counting these two probabilities. That's why we do need to replace the mu and sigma in the beginning. So once you have obtained this, now I will draw the normal graph. So basically now we need to find which is more than 1 and less than minus 1. These two regions are symmetrical basically. Okay, so I can flip this over, and then it is the same as double of the green region. So I will write this is basically same as double of green region. The green region is basically the z or z more than 1. So when you refer to the normal table, you are given the region towards the left hand side. So in order to get the green region, I will use total probabilities, which is 1. Here is 1 minus pz or z less than 1. Okay, so here is going to be 2 bracket 1 minus p less than 1. And then you can read the answer from the table right now. What is pz less than 1 or pz less than 1? So you will get 0.8413. Therefore, you are getting 0.3174. This is the probability. But when you refer back to the question, you need to find how many leaves out of 2000. So it means that this 0.3174 is for one leaf. Okay, so now expected number of leaves will be 2000 times 0.3174. Then you will get 634.8 from a calculator, and at last you round up 635. Okay, that will be the solution of this question. Right? So let's move on to the next question. Question 6. Janice is playing a computer game. She has to complete level 1 and 2 to finish the game. She is allowed at most 2 attempts at any level. Alright. For level 1, the probability that Janice completes at the first attempt is 0.6. If she fails at her first attempt, the probability that he completes it at the second attempt is 0.3. So if Janice completes level 1, she immediately moves to the level 2. So for level 2, probability that Janice completes at the first attempt is 0.4. And if she fails at her first attempt, the probability that she completes it at the second attempt is 0.2. Alright, so now show that the probability that Janice moves on to level 2 is 0.72. Okay, obviously this is tree diagram. Okay, so I can show the tree diagram first before I show this probability. So basically you can just write this is level 1. Okay, pass and fail. So if pass in the first attempt, 0.6. If fails, so it will be 0.4. So the total probability is 1. If she fails at the first attempt, then she will complete it at the second attempt with probability 0.3. That means fail, then here pass 0.3. Alright, of course, here fail is 0.7. Now, that's the level 1. Now, here level 2. So, once she has completed level 1, then she will move on to level 2. Now, for level 2, the probability that Janice completes it at the first attempt. So, here, first attempt is 0.4. So, fail is 0.6. If she fails at her first attempt, the probability that she completes it at the second attempt is 0.2. Okay, so for here, this can be pass, this can be fail. Okay, again, this is 0.4, 0.6. Now, there's no extension for this F because if she already fails 2 times, 2 attempts, then she cannot proceed to level 2. Alright? So then, now, if she fails at the first attempt, the second attempt will be 0.2, pass. So here, pass, 0.2. Fail and pass, 0.2. This is 0.8. Here is 0.8. Right? So this is going to be the tree diagram for this question. Now, show that the probability that Janice move on to level 2 is 0.72. So it means that now I need to calculate. It will be pass, pass. Okay, it can be pass, fail, pass. Or it can be fail, pass, pass. Or it could be fail, pass, fail, pass. Alright, these four possible attempts. So now my probabilities will be okay, at first pass, pass, pass. So 0.6 times 0.4. Wait, sorry. Show that the probability that Janice moves on to level 2. Okay, moves on to level 2. Means that just pass. I don't need to consider all this first. Alright, so just move on to level 2. So which means it will be pass the level 1, then we'll move on to level 2. Or fail the level 1 and then pass fail in the first attempt in level 1 and then pass in the second attempt. Then she will move on to level 2. Okay, so here all is plus 0.4 times 0.3. Okay, then here you will get 0.72. So this is how we get 0.72 over here. Now, B, find the probability Janice finishes the game. Okay, so finishes the game means that she has to pass both. Alright, so just now my explanation is basically for the B. So which means pass, 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 fail, pass. Okay, it could be fail, pass, pass, the green color, or fail, pass, fail, pass. This will be finishing the game. So now, if you have drawn this tree diagram, then it will be easier. So now I will just write probability equals to the green color, PP. So 0.6, 0.4. Or, okay, to reach the green color here, that means it must be PFP. Alright, so here it will be 0.6 times 0.6 times 0.2. Or the third one is FPP. So here 0.4 times 0.3 times 0.4. And lastly, it will be FPFP. 0.4 times 0.3 times 0.4 times 0.2. Okay, here FPPP. Right? Wait, let me check one more time. Okay, the last one is not 0.6. It's not 0.4. It should be FP FB, fail and pass. So 0.6 over here. Alright, so when you calculate each of these, it will be 0.24 plus 0.072 plus 0.048 plus 0.0144. So at last you will get 0.3744, and now you round up to 3 significant figures to get 0.374. Okay? Now C. Find the probability that Janice fails exactly one attempt, given that she finishes the game. Okay, so now P fails exactly one attempt. So this is the conditional probability because of this term, given that she finishes the game. So you are given two conditions here. 2 in 4. Okay, one attempt. Given that is slash finishes the game. So from the definition of conditional probability, it is same as fails exactly one game or one attempt and intersect with finishes the game over P finishes the game. So we have solved the denominator in part B. So from here, fails exactly one attempt and finishes the game. Let's look at the tree diagram. So now, it fails exactly one. Let's say I choose, purple, maroon color. So the first one cannot, because already, it can be P. Okay, it can be P. And then make sure she fails in exactly one attempt. So must go to the F, then only P. Okay, or could be F first, already fails one attempt, then make sure pass for both. Okay, no more fail. So pass and pass. Alright, and also she finishes the game. So these are the two possible outcomes: PFP, FPP. So you can write down first. Probability PFP or FPP over P finishes the game. So then here, PFP is basically just multiply 0.6 times 0.6 times 0.2. FPP will be 0.4, 0.3, 0.4. So the probability that she finishes the game is the answer from previous part. Okay, which is 0.374. Then now when you count each of these, now for your information, I will not take 0.374 for this calculation because this is not yet the final answer. So for calculation, I will use more decimal places or more significant figures. So I will use 0.3744 instead of 0.374. Okay, so that you will get more accurate answer. So the numerator is basically 0.12. Denominator remains 0.3744. Then when you simplify, this is going to be 0.321. Alright, so we have come to the end of the video. Again, thank you for watching this video. Please subscribe to my channel if you enjoy watching my video, and stay tuned for more upcoming videos. Thank you. Bye.